Guess who's back? Back again. Yeah, so I'm back. It's been a while. As you can tell, I've cut off a lot of my hair. You know, the audio's not as good just because I couldn't get a microphone set up. I couldn't, get it connected and whatnot. Anyway, I'm back, and we're gonna be talking about some cool archaeological, anthropological stuff. There's of course a works cited in the description, so if you want to check out where I got all this stuff, go down below. I've got my script here. And let's get talking. Actually, today we're going to talk about my personal favorite, or second favorite hominin, Homo Denisovan. Denisovans are a mysterious group of hominins that are known to have lived in the Altai mountains of Siberia tens of thousands of years ago. The first remains of these elusive hominins were found in Denisova Cave in 2008. The discovery was made by a team of Russian archaeologists led by Dr. Anatoly Devrenko, and it was initially thought to be the remains of a Neanderthal. However, subsequent DNA analysis revealed that the bones of the Denisovan actually belonged to an entirely new and previously unknown species of hominin. This analysis of DNA extracted from a tiny fragment of bone was then carried out. It was carried out by a team of scientists led by Professor Svante Pabo. There's dots on the A's. I'm not sure how to pronounce that. Professor Svante Pabo of the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany. The results of this analysis revealed that the bones belonged to a hominin that was distinct from both modern humans and Neanderthals. This newly discovered hominin was dubbed the Denisovan after the cave in which the remains were found. Further analysis of DNA from other Denisovan remains, including a tooth and a finger bone, has provided valuable insight into the genetic makeup of these ancient hominins. The DNA analysis has shown that the Denisovans were closely related to Neanderthals, but that they were also interbred with modern humans who migrated out of Africa about 7,000 years ago. Sorry, 70,000 years ago. There's a big difference between 7,000 and 70,000. The discovery of Denisovans has opened up a new avenue of research into the evolution of humans and our close relatives. Despite being a newly discovered species, the Denisovans have already contributed greatly to our understanding of human evolution. In fact, in the next part of this series, we will explore the fascinating world of the Denisovans in more detail, including their physical appearance, way of life, and their relationship to other hominin species. So, stay tuned. Part 2. The second piece of remains that was discovered as Denisovan is known as the Zhang mandible. This mandible was found in 1980 in the Baisha Karst Cave in Zhaixi, China, but was not identified as Denisovan until much later. The Zhaixi mandible is significant because it is the first fossil evidence of Denisovans found outside of the Denisova Cave. The mandible is estimated to be between 160 and 400,000 years old, which is a significant range, but indicates that Denisovans were present in Asia long before Homo sapiens arrived on the scenes. Analysis of this Zhaixi mandible shows that it shares characteristics with both Neanderthals and Denisovans, suggesting that these groups of hominins inbred in the past. The finding provides further evidence of this complex web of interactions that existed between early human populations. Researchers were also enabled to extract DNA from the Zhang mandible and sequenced it, revealing that it belonged to a Denisovan individual. Otherwise, I wouldn't be talking about it. The DNA also revealed that the Zhang Denisovan was genetically distinct from the Denisovans found in the Denisova Cave, indicating that there are at least two different Denisovan populations. This discovery of the Zhang mandible provides valuable insight into the distribution and genetic diversity of Denisovans, and highlights the importance of ongoing research in this field. As more fossils and genetic data are uncovered, we may be able to piece together a more complex, complete picture of this complex history of human evolution and migration. Finally, Part 3. So far, we've talked about the first and second Denisovan remains found in Denisova Cave and others. Now let's talk about the rest of the Denisovan remains that have been discovered. In 2019, a team of researchers from the Max Planck Institute of Evolutionary Anthropology announced that they had identified a Denisovan jawbone fragment found in the Baisha Karst Cave in Tibet. This fragment is the first Denisovan specimen to be found outside of the Denisova Cave. The researchers used a technique called ancient protein analysis to identify the fragment as belonging to a Denisovan individual. The jawbone fragment is estimated to be at least 160,000 years old. Another significant discovery was made in 2020 when researchers from the Russian Academy of Sciences announced that they had found a second toe bone belonging to a Denisovan in the Denisova Cave. The toe bone is the fifth Denisovan specimen to be found in the cave, and the researchers used DNA analysis to confirm that it belonged to a Denisovan individual. What makes the discovery of the toe bone so significant is that it provides evidence that the Denisovans were more widespread than previously thought. The toe bone is estimated to be at least 50,000 years old, and it suggests that the Denisovans may have lived in the region for tens of thousands, if not hundreds of thousands, of years. As you can see, the discovery of these Denisovan remains is crucial to our understanding of human evolution, which is real, by the way. While much is still unknown about the Denisovans, these findings provide important clues about their existence, distribution, and possible interactions with modern-day humans and Neanderthals. That's been it for our discussion on the Denisovans. Thank you for watching. Like and subscribe.